So, hello everyone, and welcome to this presentation, to this small event to celebrate the MySQL 30th anniversary. My name is Vittorio, and I am solution engineer at Oracle MySQL. And today's topic will be a discussion about the full stack approach. So, how to supercharge or revolutionize a little bit again your applications with MySQL, JavaScript, and REST APIs all in the same package. So before jumping to the discussion, let's have a look to the points we'll cover over the next 40 minutes. Uh, we'll speak about where is MySQL now standing and where it came from. Then we'll speak about the MySQL application journey, and we will see how JavaScript joining the MySQL set of functionalities has changed the ways you can work with your database stored programs, and how REST APIs joining also the set of the MySQL native functionalities has changed how you can interact with your database as well. And then we'll see how to ensure continuous uptime of mission critical applications. And we will wrap up. We will have a short thought about embracing the modern stack and how this is a new chapter for MySQL. And we'll have the Q&A. So save your questions and let's start. All right, so the state of the Dolphin 2025. Where is MySQL now, and especially where it came from? So MySQL this year is celebrating the 30th anniversary. So we are all super happy about this very important milestone, which started long time ago. So the first MySQL components and storage engines are backdating to 1995, uh, where the first storage engine was written, which was back in the days MyISAM. And then in 2001, the first stable release of MySQL was launched by the back then MySQL AB. In 2003, MySQL AB acquires Alzato, which was an Ericsson division, which is the division responsible for the creation of the NDB storage engine. So our MySQL NDB cluster was born, which is very widespread in the telecommunication business still today. In 2005, Oracle acquires InnoBase, the company behind InnoDB storage engine, and we start seeing how, for some odds of the destiny, the fates of the two companies start to merge, because in 2008, Sun Microsystems acquires MySQL AB, and shortly after 2009, the Oracle acquisition of Sun Microsystems started, acquisition which was completed in 2010. And the history says that the acquisition lasted so long because of MySQL and because of the antitrust organism of the European Union blocking the acquisition, and Oracle, of course, had to show that the two products are non-competing, so it will not constitute a form of monopoly to have them both. And this has been a journey of continuous innovation. So, especially since Oracle acquired MySQL, the functionalities have seen a boost. MySQL have seen an investment as well in terms of people. So we have been adding business continuity functionalities. We have been adding NoSQL functionalities, cloud native functionalities with the Kubernetes operator, disaster recovery, and more. JavaScript as well, REST APIs, and news of those days, which we'll not cover in this presentation because it's yet It's GA, but it will be announced publicly at Oracle event in the US in those days. Generative AI as a native component for MySQL. So MySQL is the most popular open source database since 2012. Uh, According to DB Engine ranking, according to JetBrains survey, has always been holding the top position and among the open source database, according certain indexes of popularity that those independent portals are calculating. MySQL is still the most popular open source database. And as a witnessing of this fact, we do see that it's widely adopted in the market in pretty much any vertical. So social media giants are heavily relying on MySQL, e-commerce platform like Booking.com, Netflix, Uber is heavily relying on MySQL as well. Uh, SaaS platforms like GitHub, HubSpot, and so on, financial institutions, and here is where the games start to get more tight because financial institutions have normally a more restrictive policies for technology adoption, and as well, manufacturing companies are heavily relying on MySQL. So, of course, MySQL is open source, but especially some of the most restrictive companies as MySQL commercial customers, they are relying not only on the community edition, but also on the enterprise edition, which has evolved during the years. And at the high level, it still comprises the same thing, so support, management tools, and advanced features. Just those features have been adding up over the years. So for example, today we see a management tool set which includes a Kubernetes operator and advanced features, so native servers, plugins, which are including as well JavaScript, plus all of the other usual security features which you would expect when you place a database into an enterprise context, or when you place pretty much any IT solution into an enterprise concept. There are people which will be asked who's going to support these. There are people who will be asking how do we monitor, backup, and overall manage this. And there are people who will be asking what about the security? What about this and that security particular feature? So this is it. The Enterprise Edition responds to the need of placing MySQL into an enterprise context. Now, MySQL, we have seen that it is yet the most popular database among developers. And let's see a little bit its application journey. So as of today, there are two MySQL releases apart from community and enterprise. So for both community and enterprise, you have two types of releases. You have an LTS release and you have an innovation release. LTS release as per the operating systems, as per Linux operating systems, for example, it actually includes a feature set at the beginning of the release, and then it includes patching, security patching for a wider span of time, which in this case, it is 5 years of general patching plus 3 years of security patching only. Innovation release, on the contrary, it brings new features roughly every 3 months, but it has a shorter patching cycle. Basically, there is an innovation release, and then there will be the next innovation release. So with the fact that it brings new features, if you want to use innovation release in production, there might be cases when you'll have to test it against your application, while patching of an LTS release is just a minor task to perform without testing involved. So this is it. The current LTS version is 8.4, which will be supported until 2032. The next LTS version will be 9.7, which is due to be released approximately in April 2026. And it will be patched for additional 8 years. Everything in between, it is innovation release. So what is, now that we have seen which versions we can use, what is the typical MySQL application architecture? Well, it's pretty usual, pretty boring. Let's say it's something that all of us, we know very well. There is the database, then there is a backend server which sends SQL requests to the database, and then there is a frontend which sends normally HTTP requests to the backend. So it's something very consolidated. If needed, we can add some sort of high availability in different layers for the backend. Depends on what we're using. For MySQL, we can add high availability, but the schema over the years hasn't changed much. MySQL is normally used for the data storage mainly, so I haven't seen in the years much of application logic reside in MySQL, I would say for a set of good reasons. The backend is where the application logic normally would sit, and the front end is the beautiful visualization. And this has been it for a lot of time. Now, as I said, what about business logic? Business logics normally sit in the backend. If we need business logic in the database, we add store procedures and store functions, but which we can use with create procedure, create function, and then we can call. The language of the store procedures is standard SQL. There is some form of looping, but overall, if we would like to have some additional business logic sitting on the database, this is a lengthy task because the SQL store procedures are ending up being very long. In the majority of the cases, they're ending up being very long, difficult to debug. We have practically no tools for debugging them. So traditionally, MySQL has not been the best place where to put any business logic. This is until today, until let's say a year ago, when we have introduced JavaScript native support with the task of modernizing the way we approach to store programs. Now, this has been released as an enterprise functionality, and essentially based on an embedded version of Oracle Graal VM. And the task it is to modernize the way we approach to store procedure and to give the possibility, if someone wants to keep store procedures in the database and to enrich our applications, perhaps with additional business logic. Now, why JavaScript? Well, it's an obvious question because JavaScript is one of the most used language by developers, because 90% of all web pages are using JavaScript, because support is supported practically everywhere, and it has a very wide development ecosystem. So JavaScript was kind of an obvious choice, but we'll see it might not be the only one. So let's give some pills about JavaScript support inside MySQL. It is based, the JavaScript we support is based on CMA script 2023 and runs in strict mode by default. So supports standard built-in objects like objects, functions, math, date, string, and so on. Um, it has a scoped execution environment. So don't expect access to the file system or to the network or to Node.js. And this is because of security reasons, essentially. The execution model is single-threaded per query. So JavaScript instructions are translated to SQL queries under the hood by the very same Graal VM, and every query coming to the database, it will take one thread. It has asynchronous features are simulated, but it's better not to use those because it may show non-deterministic behavior. Overall, it interoperates with SQL. You can call SQL instructions from JavaScript routines or JavaScript instructions from SQL routines. So the core component of the JavaScript runtime inside MySQL is the multilingual engine component, MLE. Being based on Graal VM, it means that JavaScript is just one of the languages that can be supported. That's been the first one, but in the futures, additional languages may come. So to install the component, long story short, you need to look for the component MLE in the components, and you need to perform the install command. And once it has been installed, you can see from the performance schema error log phase, like the activation phase of the component with the allocated memory for the Java heap by default. Now, the command MLE status will give us all the status variable for the MLE component, so for the JavaScript essentially, and will give us as well the memory allocated for the multi-language environment that in this case corresponds to the memory allocated to the Java heap, which by default is 1.27 gigabytes. Don't ask me why this default has been picked, but can be set, it can be changed once the component is active. Now, how would we define JavaScript programs? Essentially, it is very easy. We can define both store procedures or functions, and it works like that. We change the delimiter, of course. We create a function, and we define via the syntax that you can see on screen the function to JavaScript language. After that, we write our JavaScript code, we change back the delimiter. It's very easy. It has auto type conversion, so the SQL types are transparently converted into JavaScript types. And as said, it's interchangeable. You can have SQL inside JavaScript or JavaScript inside SQL. So this is an example of JavaScript inside SQL. You can select and you can call JavaScript functions, essentially. And there's an example of SQL inside JavaScript. You are inside this JavaScript store procedure, and you can call a query to the database if you need to. So as we can see as well, some additional reflection, we can see that the store procedure, the function takes input arguments. So we can pass arguments from the application if needed, and the procedure code can process those arguments accordingly. The data type conversion is pretty much automatic and transparent between the MySQL environment and the JavaScript runtime. There is option to customize conversion for MySQL data types, as like, for example, big int, decimal into JavaScript strings or numbers. Now, let's come to the interesting part. I know you have been asking this question to yourself when we start talking about JavaScript. Does it support libraries? And the answer is yes, it does. You can store by storing JavaScript library code into MySQL, and you'll be importing them in a table essentially. You will be able to use JavaScript libraries, the ones which are compatible with ECMAScript, inside your JavaScript code in MySQL. And of course, you will need to add a small SQL statement at the beginning and at the end of the library, but this is via simple file manipulation like append and prepend. This can be done. So this system integrates with code editor like, for example, VS Code, and VS Code has a plugin for MySQL shell connection. So you can use, for example, VS Code editor to write store procedures directly into the MySQL database. And it is debuggable. It will throw you errors. All the errors are stored in a status variable, which you can call to check what error the store procedure has eventually thrown. And it will have status variables and status metrics, which can be observed to see how our JavaScript component is doing, how is the memory doing, the number of instruction is executing. So it takes care as well of the observability point of view. And of course, takes care as well of the security point of view with execution isolation, preventing visibility between any different store programs executed on GraalVM. They'll not share the same memory spaces. Sandboxing, so every store programs runs the GraalVM runtime in a sandbox mode without access to file system, thread management, network, or native access to the database. And it integrates very well with the SQL privileges because you can define the level of privileges for the invoker or for the definer for the functions and procedures. Now, we can enrich our data with the JavaScript store procedure, but let's unlock our data accessing MySQL via native REST API. So we have introduced a couple of months back the MySQL REST service. What is it? It's essentially the ability of connecting to the database not only via SQL or MySQL protocol, but also via REST endpoint. So every table, store procedure can be potentially converted to a REST endpoint, turning MySQL in some kind of an API gateway, for example. And of course, this has a lot of use cases which you can find application for, because it's generally easier to address the database via the standard REST protocol. And the REST service integrates with the high availability solvers. So this is the architecture of the MySQL REST service. There is, of course, the front end, which will send HTTP requests to the MySQL REST service, which can reside either in the MySQL router or directly in the database. At the moment, it resides in the MySQL router, but with one of the next updates, there will be an option as well to add REST service as a MySQL plugin natively. And we can have JSON data as a result. We can run it as a SQL extension, and we'll see how to configure it. We have automated data mapping between columns and JSON object, and we have client SDK generation and automated documentation. So what are the core features? Automated CRUD. So a table which is turned into a REST endpoint can support the CRUD operation, so get, post, put, and delete at the moment, and will map those operations automatically to SQL operations. Then, of course, it has a built-in authentication and access control with authentication capabilities via the MySQL internal authentication plugin, the MySQL REST service authentication. It supports auth 2, it supports Facebook login, Google login, and so on. It maps the users to their defined SQL roles, and it has a built-in HTTP server, which has been optimized for performance, is multi-threaded. It can serve as well static content. If you have to realize a very small application with static content only, you can host it on the, for example, as of today, on the MySQL router. It has web session management, which JWT and cookies, and it can execute asynchronous tasks. And it generates automatically with one click documentation in the OpenAPI standards, so Swagger. All right, so this is how the interface looks like. For example, I am turning a table. I can define a table if we follow the screenshot. In this case, I have defined the table CTP exposed as a REST endpoint. I can define which columns I will expose as a REST endpoint if the authentication to this endpoint is required or not, and if the endpoint itself is enabled. And I will see as well, and it can be a table, it can be a store procedure. So I can deploy as well with one click. In this example, I am managing the REST service via the Visual Studio Code MySQL Shell plugin. So I can have a right click on my REST service and deploy OpenAPI Web UI. I can give the resource path, and I will have my OpenAPI documentation to give out to developers to familiarize with APIs. Of course, it's supported by both MySQL Shell command line and MySQL Shell via Visual Studio Code are supporting the MySQL REST service. And as well, I can generate a client SDK. I can choose between TypeScript, Swift, Python, or Java. So the whole architecture of today's REST service, where I do have the REST service residing in the MySQL router with the REST service definition being stored on the database as table storing metadata. But in the next future, I can have all-in-one in the MySQL database if I am running on single instance. Of course, if I am running on availability like in a cluster, I can actually use the MySQL router as well. So we have seen the database, we have seen the JavaScript, we have seen the REST service within the database. Now, I have an application developed. How do I running on MySQL? How do I ensure continuous uptime? So do you remember MySQL asynchronous replication where I had one source sending the bin logs to one or more replicas? Well, this was good, but it lacked, for example, automated failover. This lacked data consistency due to the asynchronous nature of the process. So the data were shipped, and when they were shipped, there was no acknowledgement. Eventually, the network between the source and the replica could get lost, and I could eventually lose some data. So to correct this, we have introduced back in 2017, which has followed us throughout the way until today, InnoDB cluster, which is a more modern high availability solution with integrated automated failover and data consistency based on group replication mechanism, which is managing the group membership of the nodes automatically. It's handling network partitioning. It performs, of course, the failover, and then it relies on MySQL router, which we already know from the REST APIs for the routing part. So the application connects to the router, which transparently will send over the data. And for configuration, we do use MySQL shell, which has APIs to set up a cluster with 9 commands, 9 short commands, I would say. This solution guarantees recovery point objective of 0 and recovery time objective of seconds due to the automated failure. How does it work? If the primary member crashes, a new member is elected between a few seconds. Where do we place the router actually? Well, there is a choice of several possibilities. No choice is superior to others. It depends on what we can do. For example, we can place it together with the application in the application server, but if the application team says hands off from my machines, we can build a cluster of routers, either via operating system clusters or via load balancing of some sort. If we want disaster recovery between two clusters, we can have cluster set, which is slightly improved asynchronous replication between clusters, which will be following the InnoDB cluster primary nodes. And with an API command, we can revert the direction of the replication to switch between primary and secondary data center if we need to work from the DR side a few days a year, for example, or we can do emergency activation of the secondary cluster also with the simple API command. And we complete the story with read replicas if we want to add additional read out scalability. So let's see if this is the full stack for MySQL, where do we have high availability, we do have JavaScript, we do have REST APIs, and how we can leverage the full potential of MySQL to let's say, shape our new applications, and why not to compete with much more expensive database solutions? Because yes, there is no T-SQL, there is no advanced SQL language. Do we really need it? There is JavaScript, which is so much more powerful at this. If we need NoSQL approach, there is REST APIs, which will deliver us data in JSON documental format, and then we can execute our data transformations if we want from the application, or we can expose store procedures, which will deliver us via REST APIs or really transform data by our JavaScript code. So putting it all together, MySQL is more than just a database. It has become, with the year, a powerful application platform. Integrating JavaScript, which, as I said, it's a very powerful combination because it fills the gap, let's say, with the database solutions, which were considered more premium. And it simplified data access via REST API. So now it's up to you to start planning your new projects based on the new MySQL functionalities. Thank you for the attention. Question time. So let me switch on the camera again.
So do we have any questions?
If there are no questions at the moment, you can reach out to me at a later time.
So Vittorio, do you hear me?
Yes.
This is the question booth.
This is the question booth.
Yeah. Cool. Do you hear me?
Yes.
Cool.
Hello.
This REST API stuff, this is really exciting, but where do you put the business logic in this case? So it's sort of chimney architecture in this case, right?
So those are, it's not mandatory to use all the functionalities at once. Like you can put some of the business logic, which would require, for example, complex queries in a JavaScript store procedure, expose it via REST API, but you can put all the rest of the business logic where you have always put it.
So you basically still need two solutions in this case.
Not necessarily. It's really up to you. You can put all of the business logic in JavaScript, of course, in the store procedures, and you can call the store procedures via REST APIs.
Okay, then how do you plan to expand this JavaScript stuff? So it doesn't have, I believe, like unit tests and other stuff from ecosystem. So I believe it's just a small scripting solution for now, right?
For now, yes, it's a scripting solution. And I am even not sure if we plan to expand on that level, but for example, to fill the gap with other systems, like, for example, MS SQL, where you do have T-SQL, or even Oracle DB with PL/SQL. This is the aim of the function, like to ease lengthy store procedures, which would take a lot of SQL code, and make it more concise with JavaScript.
Yeah, so more sort of DBA type of scripting, right?
At the moment, yes, but of course, we do not support unit testing, but developers will start using it and there will be a demand for this kind of functionalities. I do not see why not.
Okay, got it. Thank you.
Thank you.
Yeah.
Yep.
You have to choose the slide.
I'll choose later. Yep.
Okay. More questions?
I have two questions. First was about you mentioned automatic data type conversions in between the scripts and database. So what exactly happens with non-matching data type sizes, such as big int, where I believe MySQL is a lot bigger than supported by JavaScript?
So if I understood correctly your question, you are asking what happens in case of mismatch of data type size. Yeah.
Yeah.
So the maximum which can be fed, of course, size of the MySQL data type, because that will be the data type it will be resolved to. Yeah? But I'll ship more precise information to Edgar's via email after this talk, because I'll have to take a look to the documentation how this has been defined.
Can you send me for your contact so I can forward that? Okay?
Or maybe you can put it in Discord,
Yeah.
which nobody uses. Thanks. Right. And the second question was about some kind of complex logic within the stored procedures, where, for example, the queries which are calling them are killed by either long-running queries mechanism or timeouts or whatever. So how is synchronization handled in between updates and whatever the procedures are doing within the database?
Yeah, this is a very good question, and this is handled by the standard mechanisms of the database, because all of the procedure instructions which are interfacing with the database will be turned into a query, and those queries will be generated by the procedure. And if there is something which will be, for example, locking that set of rows or something like that, that goes as normal queries from SQL procedures.
Okay, thank you.
Thank you.